Good evening, ladies and gentlemen. Bruno, could you please close your sharing for now? Perfect. So I will introduce you. So, good evening. We have opportunity to invite our guest for the second time. It's Bruno Veronesi. We already had one TDD and pair programming session, but it was workshop with limited number of participants. So that's why we decided to ask Bruno for second turn. And today he will have a presentation about TDD and pair programming. It will be longer, more detailed, but you will have also possibility to ask questions. So please ask via SLI.DO. You can write there a protest 95 code as usually, or you can also use chat in YouTube. So no more talking from my side, and the floor is yours, Bruno.
Thanks, Lucia. I will start sharing the screen. And yes, right. So welcome everyone. This is a presentation about, it's a lot about myself, but it's also about TDD and pair programming. At some moment in my career as a developer, something happened that that I had to rediscuss everything that I thought was developing. And I understand this is something that can happen to everyone. I think it's a good change. And I want to share with you why I took, let's say, this way, and how I learned these two techniques, TDD and pair programming. I would say that for me, they are basically great tools when starting a work, or when working every day, or just to get the things done in the correct way. Helps also, they help a lot also in keeping the pace of your daily development without strangling yourself. You know that we live in a very competitional kind of environment, and keeping the speed of our development, helping our companies to keep the speed of the development, being able to deliver is what makes us really good professionals. It's what divides us from the average professional to the good professionals. Also, they are tools that allow for learning collaboratively. And you will see what I mean. But in a nutshell, is really in the learning together and sharing the mental work that is behind our work. Also, I learned all these techniques from the community, and I would like to give them back and to share them back, keep them alive in the community. I felt that my life was impacted in a very positive way by these things, and it would be a pleasure for me to introduce others into this. So let me introduce you how I started the TDD. One day, a friend of mine gave me a bunch of videos from Uncle Bob, and he told me, "Look, watch these videos. They are really, really cool. Watch these videos, watch them." Okay, I started watching them, and something inside me started to change. It took me 3 years to actually start getting the change in a more formed way, but it was a breaking moment for me. I started seeing how this technique worked, and I was convinced something was missing from my toolbox, And this was the thing. With TDD, for example, you can handle legacy code in a very good way. We know that this is one of the biggest nightmares in our profession, to have code written by someone else with completely different mindset, and you have to fix it because it's there is a bug there. It is very difficult for me it has been very difficult for me to express how TDD and how this thing works. So also this presentation is for me a stimulus to go, let's say, to get out of this comfort zone and to take the opportunity to give back to such a rich community that we all are part of. So TDD is a practice. This is why it took me so long for getting it. So it's something that you will see, we are going to get, it's complex. So we are not going to learn everything there is about TDD tonight. I am still learning it, even after 15 years of development experience and more than 3 years actually of TDD practice. I'm still learning. I'm still discovering what TDD can do for me. And this is also the reason for this presentation, put all together and somehow a moment of pause for me and a moment of sharing to you. Like we are in a sort of bar and talking about this weird thing, and I am giving you my opinion about this. So, in a nutshell, what is test-driven development? If I would have to define it in a very concise way, I would say that is a form of decomposition. It helps decomposing problems. It is a sort of problem-solving technique. How does it work? The first thing that you write a test in which you describe how your dream application should work. For example, if I send this, if I make a question in a certain way to the application, what it should answer, you execute the test. This test should fail because your application is not there yet. This is why it's called test-first approach. We first write the test. We first put a sort of what we want. We then write the production code that verifies the condition of the test. We execute it and it should be green. So it should be red for the right reason, it should fail for the right reason, and should be green for the right reason. A bit like saying, let there be light, and then turn on the light. So you first see what you want, and then you write what you want. But you need to be explicit. It forces you to be somehow upfront from what you want. Not that you start bashing code and maybe you get something right. So the technique has been formalized by Ken Beck in the 90s. What helps a developer is to find what is the next step to finish your current the current task ahead. It's a decomposition technique in which you put yourself in front of each step one at a time. You go one error at a time, one test at a time, and you make the test and the code, the test and the code. After a while, it should be like a music, like a sort of rhythm. It's a method to get things done, so to develop, and it's not a testing technique. Maybe this is the great thing, the great discovery. Even if the name has test in it, it is a development technique. It doesn't collect the documentation that arguments client confidence in a product. Right. So there are 3 rules in test-driven development. That you are not allowed to write any more of the unit test that is sufficient for failing, and compilation failures are considered failures. You are not allowed to write any production code unless it is to make a test pass. And you are not allowed to write any more production code that is sufficient to pass one failing unit test. These are a bit of a prescriptive way to say that you have to write as little test code as possible, as little and simple production code as possible, and focus on the rhythm. A bit of one, a bit of the other, a bit of test, a bit of production. Let's see an example. I will make you a sort of stylized example. Let's say that at some point you write your test. You are without any, you are from the desert application, and you've started writing your first test. This will fail for some reason. For example, the class is not implemented yet. This is a perfectly working reason. After you did the test that fails for the correct reason, you write the production code and you re-execute the test. That should be green. So this is your first entry in this sort of double entry book. Test what the system should do and how to do it. Then you pass at the next step, which is the second test, which fails for another reason, maybe because that code is not there yet, like before. You write your code, you re-execute the test, and there it goes. One, the other. A bit of test, a bit of production. You will see that implementing in this way, after a while, after you start implementing the first, let's say 3-4 methods, you will see that some things can be done a bit better. You could, for example, in doing the easiest solution for the production code, as we saw before, brings you naturally to duplicate code. And at some point you will say, this code is too duplicated, I want to refactor. I want, for example, to put it together so that it speaks more of the domain name. For example, you are, for example, putting together the machinery for an accounting system. This accounting has, I don't know, the calculation of the amount, the calculation of the taxes in a certain region, and then maybe you have some discount. These things has to be done in a certain way, and you will start taking these parts, and they will start talking about the domain language. There will be structures that are repeated that are going to be factorized. So it will be time to, as we say, refactor. What does it mean, refactoring? Change the code, the structure of the code, but do not change how the application behaves. For example, you can rename a variable. This is quite safe. Most of the time, changing the name is not a big deal. Sometimes you hit on a name that is already used somewhere, but most of the time, this is not an issue. When you refactor a method, it can be a bit more risky because maybe that the execution in that method would change something in the context, and the method alone just copy the code, paste it somewhere else, and keep it in a different method would not work because reason of the code. Can you change the order of instructions? Because maybe in your code, you have 2 instructions that if you maybe flip them over, you will see a pattern and you can factor that pattern. Can you do that? Can you not do that? This is where, this is one of the points in which TDD shines. It lets you have a record of what are the cases that you want your system to be working. And when you refactor and you work, and you rework your code, you can change it with confidence that what it was important and true before is still true after you work on the refactoring. Test-driven development has 3 phases in the classic approach. The first one is the fail phase. We saw that one. Then we have the pass phase, in which you write as little and as simple code as possible. And then if this code is possible, is refactorable, is something that you can factor together with other things, with other part of the code, so that it makes more sense and it doesn't repeat the code, doesn't repeat the lines of code, for example. You refactor, but always keeping you in the green. So after you refactor, you shouldn't go red. Your tests shouldn't fail. They should still pass. And then you can continue, right? So make it fail, make it pass, make it better. This is the essence of the rhythm of test-driven development. Divide your problem in little chunks, very handleable, micro problems. Create a test that fails for the first one, make it pass, make it better if you can. Next one, make it fail, make it pass, make it better. There are 2 main approaches in TDD. One is called the classicist approach, in which you discover somehow your application. You start from scratch without any design up front. And it's a very much bottom-up kind of approach. The code and the design for your code emerges from the constraints and the questions that you put into the code. It's like you test a little application, you are red, then you make it green, and you discover, for example, that inside the applications, there are actually modules or other little pieces of dependent things that help you think about the application, and you during the refactoring phase, you bring them out. This is the classicist approach. The modules somehow born from other modules. The other approach, the so-called outside-in approach, the application is much more designed with test and the context of the application in mind. This is especially true when you are working with pre-existing code that has been already designed, when you are intervening in putting new functionalities in a code that was already doing something. Most of the choices and most of the design is done up front, and it's a top-down kind of approach. When you test, you already know that you are going to have interfaces doing something else. You are going to make the test green using probably mocks. This is why it's also called the mockist approach, because you fake the rest of the system. You just work on that unit. And during the refactoring, usually you don't have great changes of the design, because much of the design is done in the red phase. And this, to me, is the great tool to work with developers, with QA developers. It's working with someone that has a QA background. For someone like me that has a developer programmer background, in this approach, let me design so much better systems. And the fact that you have someone that is thinking so much about the quality, even if they are not super programmers and they are not giving you feedback on the design, just the fact that they are there and they answer your question and they make you questions, just this changes the design that you are putting into your product, and improves it positively. So we said it is a practice. It is an agile practice. And it can get months to get the hand that you can say, okay, I can start doing something serious that is, let's say something serious, I mean something commercial, something that you are paid for, something professional, to start doing something that is a product. It's not something that you say, okay, I will try, and in 2 hours it's done. It takes a while. It takes some practice, actually. It is a bit like riding a bike. It is a tool. It needs to be learned, and that's many benefits. To me, the main benefit is that the code that I wrote from when I started using it is much more reliable, much more robust. Those little tests are actually the low-level documentation in how your system works. They are really requirements and documentation that executes. It's something that computes. It's documentation. It's real documentation. We know something written completely separated from the application. And also how much easy is to express how much easy is to express your design using from the test perspective. Let's say that while you are writing your test, if it's very difficult to express your test, it is usually a yellow flag, maybe not a red flag, but a yellow flag. See, yes, for your application design, because it means that it's difficult to express that concept using the existing business concepts that your application has. So it's also a form of feedback in that way. So it is a bit about testing, because there is something that executes and creates a track, a record of what the application is capable of. But it's a byproduct of the technique. The core of the technique is the decomposition of the problem, writing something that was not true before, change the system so that it's true, and make it better, right? So more benefits that I found in test-driven development. Yes, sometimes, to me, at least, it used to happen that I was lost in the big features that you do. You don't really have a track. If you don't follow this technique, you don't really have a track that what you are really already able to do with your system, and what is lacking. And if you are short on time, being able to say where you are and what is system really doing can change the way of the type of conversation that you can have, for example, with your product owners. You can tell them, my system at the moment is doing this. To do the next step, I need this time. Is it worth it? You need to know where you are. You can guess it, but in this, with TDD, you actually have a real proof of where you are. It's easier to solve smaller problems, and it also gives you an idea of what areas that you are missing. Another thing that test-driven development can help you with is redesigning your system. We know that sometimes we put a new feature in our systems, and this new concept, this new business concept, is putting in discussion how the other business concepts are in relation between themselves, and the fact that you have to put a new condition, it somehow forces you to change the structure of the rest. Sometimes we don't do that. Sometimes we just hack something inside not to have to change everything. And this is because we don't have anything that tells us if the system is still doing what it is supposed to do. So it allows you to recompose and refactor. And by recompose, I mean, you know, when the word design comes from the Latin, that basically means to mark on the paper. When you design, you are marking the lines between inside and outside. Having the possibility to redefine what is inside or outside the module can change your performance in doing a work, right? So this is my main takeaway for TDD. I think that TDD saved my life because I don't fear broken builds anymore. I don't fear to have done big mistakes in the system I'm working on. I am a faster developer for this reason, because when I work on clean code. When I work, the code that I have there is I designed it in a way that makes sense, and I redesign it every time that a new concept arrived in a way that makes sense. This made me a better development, enabled me to understand and make a real continuous integration system that is the chimera of the last years, with reason to me. Got me to design and not follow patterns. You know that there is a phase in the life of developers in which you are just following the pattern. You are I don't know, a Spring developer. You are a .NET Core developer, because what you are doing is what you are able to do is to write small things in the context of this into this great framework, and somehow you are used by the framework. With a better design and the ability to change it when you need it, you are really using the frameworks and not a bit victim of these frameworks. And I was very enthusiastic. I started learning all these things, and it filled my head with, I don't know, with the sacred fire, with the, I thought that that this would change the life of everyone and everything. So I really wanted to introduce it in the company I am still working on at, and I said, okay, I will introduce it. I will tell the others. I will bring them the good news, the buona novella, the evangelium, whatever you want to say. Forgetting of the rule zero of every change. If the other people didn't see a gain in what I was saying, they would not go through the pain of changing it. Because adopting TDD in yourself as a professional is a pain. It takes a month to overcome the pain and start to be fast as you were before. So this is the reason why probably you don't want to start using it at work right away, the moment you finish this presentation. And at the beginning, it's really difficult to convey all the powerfulness of the technique without trying it, without really seeing how your work changes, the way your work change. So how can you introduce this thing in your environment? There are a couple of ways that if you, like me, are an enthusiastic of TDD, can introduce it to your colleagues. Probably this is the best way, the kill the bug way, in which you using a bug, which is, as we know, just a feature that is not yet documented, and you express it with test-driven development. You show your colleagues how it executes, that the tests fail. you change the system so that the test is green, and they will start to see how this technique can change the way you work, because this is a shift in the way you work, at least as I see it. Another way is a bit more the consultant way. This depends on of course, how you get to a company. You can get to a company and be a consultant or be described as a sort of super senior figure. And at the beginning, you have this sort of halo of sacrality that lets you say just the simple word, okay, oh, I would use this technique to solve a certain problem. And you can organize, for example, a mobbing session over a pair programming session if it's just with another person. We will see these words in detail. And show directly. And I think that also this can be a way of introducing it. This is how I fall in love somehow with this technique. And I think that if you do this introduction, can really change the way that you and your team work. When not to use TDD? This is another very interesting question. If your code is not going to be used again, if it's, for example, something that goes, for example, if you're doing a spike and you're just testing a new technology, or if you're doing just a bit of code to understand how you are going to interface yourself to another system, probably you don't want to go through the additional cost of TDD. TDD starts to pay off, let's say, from the second feature of your application. The first feature costs a bit more, the second feature costs less, the third less, and less. So the more feature your app is going to get, the more, the faster TDD will make you. So we are at half time, and maybe we can, if we have any question, maybe we can answer them.
Yes, we have two questions. You were talking about how to introduce TDD in the company. And here is a question from Alina. What preconditions should be achieved for implementation TDD in the team or in the company?
Preconditions. Having an agile environment helps a lot. TDD is part of XP programming, so it is an agile technique, and I would say that the condition is have a moment of great pain for your team. When your team is slowing down and it's having a lot of bugs and it's slowing down the performance, you know, when the architecture starts to show the code, that is the moment in which with TDD and with a bit of refactoring, techniques of refactoring legacy code in inverted commas, in that way, in that moment, it's the right time to introduce these techniques when there is a pain of slowing down. TDD helps you go faster. So that is, to me, the answer. Next question. Hopefully I answered. Alina, tell me if I answered. You are muted.
My favorite bug those times. So the other question from Alina is if there are any main problems and cons in TDD and how to solve them.
Main problems. Let's talk a moment about data by TDD. It's a complicated technique and requires a bit of, one would say, overall view on the project. It happens sometimes that testing that creating tests at a certain level on the testing pyramid, you guys know the testing pyramid. If you are in the unit test and you create a lot of unit tests for the implementations of the let's say leaves of the leaves classes of your app, you can actually have a lot of let's say brittle tests, and you can have that changing something in the implementation, even something simple. It breaks a lot of tests. In that moment, that is the moment of refactoring, not continuing with a new feature. So I would say that one of the pitfalls is not understanding that at some point, if your tests are to be brittle, it's moment to refactor. And if you see that your tests are too much coupled to the behavior of your of the implementation and testing too much and being too much connected to the implementation, you could also ask yourself, it is the moment to delete those tests or to change them so that they don't check the implementation and actually check the behavior, or maybe the module before. Maybe you want to make a step behind, use those tests on the module before, and try to understand if your design there is working, because usually that is a problem with design. Another problem is doing TDD wrong. For example, in the pyramid, doing TDD on the GUI level, and that is even more dangerous because those tests start to become very slow. And if the tests are slow, your iteration is slow, and you lose all the momentum that TDD gives you. So it's a technique to be used at the right level of the pyramid, which basically means absolutely in the unit, in the integration, depends, absolutely not at the GUI. If someone is TDD in the GUI, they are doing, stop them and tell them, no, don't do that. Don't kill my company.
So I have an additional question. In your company now, are you using TDD?
Yes.
And if you are using it, also other guys are using TDD?
Yes. I cannot take the merit of having introduced it, because as you probably noticed, I made a lot of mistakes in trying to introduce it, because I know that there is a reason why I know how it doesn't work. And but in the end, the pain was so great that it was introduced. Turned out also that other people were on the same boat, on the same kind of growing. And right now we have a very healthy core, especially on the most senior developers, that think that TDD is the right way of developing. And if some code arrives in code review that doesn't have a good suite of tests that makes sense, that code review is not going to pass. So I would say at the moment, yes, and made us much faster actually, and let us also not be victim of small bugs. I can think of many small bugs that we dodged just because we were able to express easily a strange situation in TDD, and we adapted the system.
Perfect. So thank you for now, and it's time for pair programming.
Yes, it's time for pair programming. It's time for pair programming. Two people doing the same thing. That sounds very inefficient. I know. But bear with me. I will try to convince you and to show you why to me now doing something alone is the wrong way of doing it. So how did I learn this technique. Again, we are in our little bar. It was this was really 3 years ago. And I was in an event. It was called Socrates, Software Craftsmanship and Testing. And I first saw this guy all together in a room doing code all together. And I saw, oh, these guys don't have 2 computers. I stayed there and I understood that actually there was a technique there. They were collaborating all together to get something done. So it was really teamwork. You know that sometimes we say, oh, we work in a team, but everyone is working alone. They really show me there is another way of doing these things. And I thought it was so cool because I was learning so much from them, because of course I joined immediately. I was learning so much from them. And I saw also the others that were learning. And it struck me, it's a tool for learning. It's a tool for sharing the learning in a safe space. Why do I call it a safe space? Because nobody forced me to join the first pairing and the first mobbing. And if anything reminds of this presentation, please make it that it's important to have a safe space to do this technique, and it's important to be pulled inside the technique and not to be pushed to do techniques. Because one of the anti-patterns, as I showed you, is exactly the one of someone that arrives with, today we need to change because we are doing it wrong. People don't like that. And most of the times, everyone is doing the things in the best intention and the best way that they can, right? But anyway, I loved the pair programming because the first time that I did a mobbing or a pairing, I was in a safe space and I decided to join. And instead of someone telling me, oh, go join, I wouldn't have done that. Pair programming. Interesting, but let's talk about code review. What is code review? It's the antipathic practice of finding mistakes in other people's code. It's not really that, of course. It's a way of sharing knowledge. It's a way of not having maybe too many junior engineers sometimes ruin the perfect architecture of your application, or to give them feedback because they are learning, because everyone is learning, or give feedback to other people, to have feedback on your design, because this is sometimes not underlined enough, but if you are trying to do a new design, you should have, for example, a junior to code review your code, because if they understand it, it's really clear. And so there are good reasons for doing the code review, but it's, in my opinion, it's suboptimal. It works well in a synchronous context in which you cannot work with the other person. So you write something, they read it, and then they answer you. But as we know, it can create a lot of rework. When, for example, after the code review, you put the code review, it takes them 1 day to have the time to go through your code review. Maybe it's not so small. Maybe there are changes that you have to do, and you should say that the other day, and day after day after day. It also creates a division in the ownership of the code. This is my personal opinion. Sometimes I saw dynamics of I will do these things, they will not notice, or okay, even if I think that they are wrong and they want me to do something in a certain way, I will do it. I will not discuss because I want this thing to pass. Because for you, it's their problem. It's not your problem as a whole development of a certain company. It's a bit of us and them. And maybe it's them that need to change. No, sometimes that happens. And it's prone to make the life of people miserable, exactly because just for a code review, maybe especially in the case of gatekeeping, it can really take a lot of time, and something that could be done in 1 day, it's done in 3 days, and it's super frustrating. But it's better than nothing. At least you shared your code with someone else. You're not the only one that knows how this code works. Your design, at least someone else has had a look at the design, and you are sure that you are not, let's say, making these mistakes in the system. But who would be the only person that does the code review perfect? Because the code review, as we see it, the perfect code review would be, you do your code, you put it in pull request, someone else sees and see, wow, great code, approved, and go. This is the way in which code review is performant. It's effective, right? Who is this person? How does this Dr. Manhattan of the development looks like? It has amazing programming skills. It has amazing design skills. He knows perfectly the domain of your application. He remembers all the rows and all the little commas of your application, and knows when, for example, something will create a problem, or where it wouldn't, or where it even fix it. It has the testing skill of a senior engineer. It creates automation. It has the automated test. All the tests make sense and never break for the wrong reasons. They are not flaky. There are no useless tests. The tests that we were talking about before about the GUI. People that TDDs the GUI should burn in hell. Not that the GUI cannot be done in TDD. Of course, it can be done. But probably you are not composing the a GUI framework, right? This perfect programmer has the perfect understanding of what the customer needs. They don't need to ask the product owner, because they know better than the product owner what the customer needs, and have the focus to continue for days. In our profession, we have a lot of, we have a great number of people with ADHD, and they have these days of amazing focus, and they can continue without eating and continue. This is an anti-pattern, but sometimes this super developer is the paragon of development is seen like this. And I want to tell you, and I want to convince you that pair programming is going to help you build the perfect developer. And how you build it? With the fusion, with the Dragon Ball technique of fusion. You put more people in the same developer, and the sum and the interaction of these people all together, they create a virtual, somehow, perfect developer. You basically rediscover the teamwork. And this is actually how pair programming is born. It is just create a great developer from all the developers that you have, and giving you the power and the focus of everyone. Because as we know, developing, it's very intellectually heavy, and you have focus for a while, for an hour, 1 hour and a half, and then your focus starts to go down. If you would have someone that helps you maintain that focus, and that is sharing the how can I say, the cognitive heaviness with you, that will help you a lot. It is somehow like moving. You know that people that move your delicate things in a house moving usually work in two people. There is two people carrying, for example, this is a dry machine. Why there is two people? Because it's less effort. Maybe even if someone would be strong enough to do it alone, would it make sense to exert yourself, to risk to break the thing or break yourself just for doing something in more time? Because in the end, it's more time alone of what you can do with someone. You do it with someone, you bring your dry machine, you bring it up the stairs, and then you go back. And most of the times, nobody hurt yourself. Try doing that with going up the stairs with a dry machine alone. Not an easy feature. How does pair programming work? There is a by the book kind of definition that puts two people in a team. One is the driver, that is the only one that is allowed to use the keyboard and the mouse, and the other is the navigator. It is the one that decides what to do. It's like in rally, that one says, to left, to right, and the navigator tells the driver where to go, right? Why this approach? What is the idea behind this? What we want is that nothing goes from the head of the developer directly to the application without being said out loud. First of all, you're using your cognitive centers for logic, for logic, because talking is as we know something sequential. So you have to actually utter words that make sense. And there are things that they have to make sense also to another person. So there is a sort of filter of things that would never work, but that you can write there. And how do you switch roles? Because in pair programming, you are not always the navigator and always the driver. You switch roles using certain rules that we are going to see after. The first one is the basic switching. The basic switching is called popcorn or normal switching. I don't know, I found this term, popcorn, was sympathetic. And basically says switch when a test fails, because this is pair programming done for test-driven development. So this is where the two techniques start to converge. There is a driver, there is a navigator. We use TDD together. We switch roles when the test fails. So at the beginning, because the test fails immediately. Then, so one decides the test, and the other decides how to implement it. So I make the test, it fails. My buddy tells me how to fix it, tells me the next test, it fails. I tell him how to fix it. It works like this. This is I put it here for the slides, so you have an example, but it's just that. Switch when your test fails. When the test fails, you are not anymore the driver. The other is you are not anymore the navigator. Sorry, the other is the navigator. You become the driver, and you start working. You will see an example of this in our go live session with Lucia. So, mob programming, it's a modification of pair programming in which all the team needs to work on the same task. You need a bit of setup, you need comfortable things, application for mobbing management, which is basically a little chess clock, and maybe a bit of facilitation and cookies. That helps a lot. But you can achieve God level, and by God level, I mean Super Saiyan level, or focus and expertise and knowledge sharing. Because all your team is going to be on the same page of what you are doing. Your testers are going to tell you, this is an important test. This is something important that needs to be in the core of the application. If you have the luck of having a product owner, he will tell you, yes, this thing makes sense. And you basically, after the mobbing, you have really delivered the feature because you already know you already have your feedback, is incorporated in your system, and you are done. You don't need to wait or to prepare or to execute the test, etc. In the mobbing, when you have the right people there, when it's done, it's done. The code is already code reviewed by many developers. The testing, you're sure that makes sense. And you probably hopefully did the right thing after discussing it with your product owner. This is the kind of switching that we were talking about, the chess clock. The rule is to have pauses. Basically, this is the suggestion because it can get pretty intense in the pair, and it can burn you out. You should put a limit of let's say half day of developing together with someone else, because it really drains your mental energy, and you should have a healthy let's say a healthy policy of switching and of taking pauses. Chess clock is especially good for mobbing, but can be used also in TDD. In pair programming. This is something that I usually use, for example, with juniors that maybe are not so intentional directly with testing, with telling you the test, and can get a lot of time and can and need the time to think, but you don't want to bring the performance of the team too much down. So you somehow time box the switches, and instead of switching on the error, you switch every 5 minutes, for example, or every 10 minutes. And this also has the potential of showing the junior that maybe was stuck in a test because he cannot express it and cannot get it. You can show him, and you can, at the switch, give him a hint how to do it and how to continue. It's great for teaching. It's great for mentoring. It's great for learning. But having someone looking over your shoulder can be scary. There can be a lot of resistance to working so much close with someone, having someone telling you what to do, maybe giving you immediate feedback on what you're writing on the screen. And I don't know if you saw one of my favorite films of ever, Pacific Rim. It's probably super trashy, but I like it anyway. And it's this sort of Gundam kind of robot with two pilots that have to be perfectly synchronized to move the right side and the left side of the robot, because in the story they need to have more power, the brain power for moving it. And they basically can see each other's thought. But I would like you to think of this. It is true that can be a bit scary, but it's also one of the few ways, and probably the only way that I can think of, in which two people can really kill a super monster. If you want to fight something that is bigger than you and your body in this, you can come together, fuse, and become more than the sum of the parts. How to start your first pair? Also, this I learned in the hard way. You have to invite people at your desk. You cannot go there and say, "Oh, I have this cool technique. Let's try it. I will help you." This gets people very much defensive, and it's a mistake that I will not repeat. Ask them for help instead. If you want to pair with someone and you want to try this technique and pairing with someone, ask them for help. We are humans. We love to help, and we love to feel useful. If you make them feel useful and you show them that you are, if you open up instead of being the one that goes towards someone else, this is going to create a great environment for the pair. It's going to be your place, so somehow in your space, and they will feel safe. They will not feel like their place or their position is in discussion. So if you at the end of the pairing, you are able to tell them, we are a great team, let's continue, or it's great to work with you. What do we do it tomorrow again? It will change the way it will change the way that person perceives you, and will start to really create a pair. And the next time is going to be better and better and better. The first mob, actually, also this is something that can be somehow created and crafted if you like the technique and you think that the technique is valid. Again, the basic is to ask for help. Create a meeting in which you ask for help. This especially works in a corporate environment in which we know that meetings are what people does. And if you propose a meeting and this meeting actually has an output that is computable, you will find an easy place. If you will call them to help you, and you will see that you will get a much better response. Also, have your code visible, if possible, from outside. I tried this in a meeting room with glass walls. And if you project the code on a big screen, developers passing by see code, press like. They enter, they tell you, oh, I know that part of code. And you tell them, come, we are modifying it for doing this. Give us your inputs. Open up, not try to push it to them. This is the thing. Pull, not push. Always pull, never push. Requires some facilitation, again, because sometimes the team can get stuck and it needs a bit of get unstuck. This can be done with pauses, but also if there is someone that has some experience, can be very beneficial. So let's say the first time, try to get a buddy that already did it, or try pairing with someone and be in the team with your pairing buddy, because there is already a dynamic of, oh, why if we try this? Okay, let's try it. But afterwards, we can go back. There is this dynamic in which during pairing and mobbing, experimenting is possible. This is the main idea. So never, I will show you something, but please come over, give me your input, work with me, work with us. Right, question time again. Do we have any question?
So I have a question about pair programming. We were experimenting with pair programming in testing, like preparing automation test in pair. But frankly speaking, we didn't use the popcorn when you are switching, when your test fails, because it's about writing tests. So do you have any experience with writing tests in via pair programming?
Writing tests via pair programming. First of all, the popcorn technique, it's for developing more than making tests, as you said, and for creating tests and for writing automation tests. Not a great. I don't have really a great experience. What I would try is instead of pairing, mobbing it. Because if you get stuck in two, maybe depending on the kind of stuckness, of course, but maybe adding someone can help you there. That is what I would try.
Perfect.
Try to bring someone else, because of another thing that mobbing allows is that, for example, if you are 4 people, is actually 2 pairs, and if there is something that needs to be researched or something that needs to be tried, you can split the mob maybe in 2 pairs and then rejoin together. There are all this kind of dynamicity that can be done. So I would try mobbing it.
Perfect, interesting idea. In our showtime, we will be using pair programming and TDD as well. So if you are not against, I would like to ask you again about TDD. We have a question from Honza Švehlák. It seems that unit testing is base of TDD. How would you convince team to use it?
Unit testing. Team, I understand you are talking about developers.
Yes.
And the point is that developers, for reasons that are over me, are resistant to write tests. What the developers are not resistant to is to write application. So it's to me, it's about framing. It's about understanding that TDD is not a testing technique. It's not about writing tests. It's about writing better applications from one side. How to introduce it, I would in such a team in which there is maybe not so much need, or maybe the speed is still high enough to not feel the team strangled, and we will do anything to go faster. I would probably try with the bugs, because I'm sure that if they are not doing this, they will have a lot of bugs. And maybe with a bit of pairing. Maybe from a testing point of view, what I would do is that you take a junior developer, you pair with him preparing the test case for this bug, and then you have this junior developer put the pull request. The code of that pull request is going to be probably very good, and this will start putting the question how this guy that doesn't know how to press enter got to such a good code and such a good test.
Super, it sounds good. And about production code, Honza asks how to refactor huge old crucial classes using TDD, which no one wants to touch.
Okay, there is a technique called sniper testing. That is what I would use in that case. This thing, it's a sort of backward TDD, in the sense that you start exploring the code through tests. Keep in mind that your tests still need to fail before they succeed. Otherwise, we are not sure that what we are doing. So what you can do is to get, for example, the longest, that this can, the kind of, how can I say, a kind of a scenario that I'm figuring is this enormous class with infinite methods that nobody really knows what they are doing.
Typical legacy code.
Exactly, typical legacy code scenario. What one can do is start from refactoring a method from something that, for example, a section of maybe the longest method. You refactor this thing in a method because we know that refactoring to method is very safe. So this is something that you can do most of the time. When you cannot do, most of the time is obvious. And you start to grow it from inside. So you start understanding and putting a test around the behavior of the part, and you start composing it. You will see that when you start getting the first method, very, very easily, there are classes, entire classes hidden inside there. And so you take this method, you, let's say, sniper, take a little piece, and you start to grow your knowledge about what this thing is really doing let's say, in a cumulative way. Once you have in your test the behavior that you think that this test, that this part of the code is doing, then you can start refactoring. For the part about the red, you just invert your expectations. For example, if you think that this thing should, for example, the result of this variable, you are at the beginning and the result of this variable should be always true, put false. Fails, invert the condition. Then take something else. The meaning of this super mini method with another method. What is this thing meaning in your application? And you start composing test for a method. And this is how I would approach it.
So nice to hear that it's possible to use TDD for working with existing code, maybe also with legacy code, as well as for preparing application from scratch. Now in Showtime, we will try to show how to do TDD from scratch. So could you please introduce what we will be doing? So I will just quickly say that I will be Bruno's sidekick, because always, you know, comedians and great performance, they have always somebody who is just, you know, putting some schlag words. So it will be me.
Okay. So with Lucia, we prepared a kata. A kata is a programming exercise to improve on something. We're going to show you how we are going to do a TDD on a very simple application and with pair programming. So we're going also to switch. You will see the switch, you will see the test failing, etc. The sample application is the easiest one that you can think that we could think of, and it's called FizzBuzz. Basically, it's a child's game in which instead of a number, you said fizz or buzz. The rules of this instance will be that every number that is divisible entirely by 3, we will say fizz, and every number that is divisible entirely by 5, we will say buzz. If it's divisible by both fizz 3 and 5, we are going to say fizz buzz, as said here. So if I am the first one, I will say 1. Lucia will say
2.
I will say fizz. Lucia will say
4.
I will say buzz, and Lucia will say
fizz.
Great. And so on. So they're going to make a little program that takes in input a number and that tells you if you have to say fizz or buzz. So let me connect to my virtual machine.
I'm sharing my screen so I can show people what I am doing.
I have a little problem. My virtual machine crashed with Azure Cloud, and it's starting again. So I will need a moment.
So maybe you can say what we will be using for this pair programming Showtime.
Right. What we are going to use, we are going to be very easy, and we wanted to be as more accessible as anything. So I found out on the interwebs that the most used language is JavaScript. So we're going to do FizzBuzz in JavaScript. As a testing framework, we're going to use Jest because I like it and I got to choose. And as you see, we already divided the production code from the test code. There is fizzbuzz.test.js, which is the one which is the test code, and fizzbuzz.js, which is the production code.
So I will share my screen again, and we can show people what we are seeing.
Mm-hmm.
Or you are sharing already, so we stay with your sharing. I think that we can stay with your sharing. Yes. So I would like to ask you with which folders we will be working.
So we're going to work with fizzbuzz.test.js, which is the test code, and fizzbuzz.js, which is going to be our production code. As you see, the production code at the moment is basically just exporting a function and throwing an error, complaining that the function is unimplemented. This is in this test, it's just a simple unit test that has a description and only one test that passes. I will show you that also this test can fail with npm test. I requested you the writing on your console. You see it?
Mm-hmm.
Perfect. Test. And we have a fail. Perfect, for the right reason. Should be true. So I guess we can start. Mm-hmm. We have everything.
Perfect, Bruno. So who will be driver? Who will be navigator?
Okay, I would suggest that I will navigate you first. So you will be the first driver.
Sorry. With women, you have always the problem because they don't know what they want. So now I decided that I will be navigator and you will be driver. What's
Perfect.
About this?
Okay, I'm fine with that.
Okay, so first in our
so
test,
you will tell me what I have to tell, what test I have to write.
That's what women likes to do. So I would like to ask you to change this first mock test to testing value 1. Mm-hmm. So if answer is this 1, then it should be for input 1. Input 1, answer 1.
So we have this beautiful fizzbuzz of 1. You tell me it should be the string 1.
Okay. Could you please run the test?
Let's run the test. What should this test do? Fail or pass?
At the moment, fail.
It fails for the right reason, because it's unimplemented. Mm-hmm. We don't have the production code.
Mm-hmm. And
so it fails.
Yeah, and now it's time to quickly change roles because our test fails.
Perfect.
It's right?
So exactly. So now I am the navigator and you are the driver. So please go on the fizzbuzz.js file.
Mm-hmm.
And the simplest thing that we can do is to just write return string 1 instead of throw new error unimplemented.
Mm-hmm. So return 1 like this. Sorry.
With yes.
Okay, I have English. Yeah, it will be better. Like this.
Perfect. Save and please run the test.
Mm-hmm. So npm test. Is this correct?
Yes. This test should pass. And even if it's very stupid as implementation, should pass the first test, which is enough for our scope. Perfect.
Perfect.
So
now
it's still my turn because the test is passing. So let's go back to the fizzbuzz test.js and let's copy the test that we just did. And let's say that we'll make a new test, copy paste, and fizzbuzzer should answer 2 when input is 2.
So I'm copying from row 5, correct?
Yes.
Till only 2.
That also row 7, yes.
Perfect. And the test we would like to do is for value 2. And there is no fizz, no buzz, so just simple 2.
This test should fail because, of course, it will return 1, but don't take my word for it. And it passes. Have you saved the file?
No, that was just me checking if you are checking me.
I am.
So expectation is that it fails.
It fails because it returns 1 and not 2. Perfect. I would say that we are right. Yes, expected 2, received 1. So it fails. Now we switch again.
Okay, again, I am the queen of fizzbuzz. So, yes. Bruno, for making this this process okay, we should have a value 2. But I'm thinking if I'm working with you, if we can just return value. Not just writing 1, 2, 3, 4.
Just return the string with the value. Absolutely. Will be done, my queen, and it's ready. Shall I run the test?
Perfect. Yes, please.
And pass.
Perfect.
Amazing.
So now please go to test file and create another test, which will be for input 3. But this time we are expecting that answer will be fizz.
Sure. So I will format this. And when answer fizz, when input is 3. So fizz and 3. I will run the test. What is our expectation here?
That it's fail.
Perfect. It fails.
And can you show us? Yeah, we see that it's failed because we expected fizz and we received 3.
Yes.
Perfect. Self-explanatory. So now we are changing and I'm your driver.
Perfect. So let's go to the fizzbuzz.js and at between line 1 and 2, let's make a space, a return, and let's write if input input equals 3, return fizz. The string fizz, yes. Perfect. Let's reformat the code also here. Thanks.
Control S.
Yes, and run.
Run. What is our expectation?
Our expectation is that it will pass. Pass.
You are right. Perfect.
Beautiful.
So I'm following your orders again.
Yes. So the next test would be the next, let's say, natural number would be 4, but I will not do that because I'm pretty sure it will be correct. So I think it's more interesting the case about 5. So I will ask you to write a test that should answer buzz when input is 5.
Okay, so for 5, the answer is buzz. So saving file, running test.
Yes, and we expect this to fail because you'll be at turn 5. This kind of technique, by the way, it's called triangulation, and it is feeding numbers or cases to your application and fixing it somehow. It's a bit like fixing bugs.
Thank you. So now we are changing again roles.
Absolutely.
So could you please go to FizzBuzz.js?
Yes.
And prepare us for input 5.
How should do? What should I do with that?
It will be copy of the thing for 3, but return will be buzz.
Perfect. So I will use here.
And use this beautifier of the code. I like it very much.
I know. The format document. Beautiful.
Super.
So let's run the test. And pass. Beautiful.
Perfect. So now in FizzBuzz test.js, I think it's time to test number 6.
Perfect.
Then input. And the expected result is fizz again, because 6 is divisible by 3.
3. Perfect. So fizz stays there. I will put 6 here, and I will put 6 here. So notice how our application is taking shape from the constraint. So I will run. And fails. Viva.
Oh. Okay, I'm your driver again.
Perfect. So I like this approach of copy pasting. It reminds me of when I go to Stack Overflow. So please do the same. And if input is 6, return fees.
Control Perfect. S.
Let's run the test. So it's passing. All our tests are passing. Good. With passing tests, I don't like this fees twice. So it's the time for refactor because Perfect. I see code repetition. So I would like that instead of input 3, input 6, return feeds, I would like something like input divisible entire rest, the little thing close to the 5 equals 0 if the division rest of, yes, input divided, yes, 3 equals 0. Perfect. So this means that is divisible, return fees, and please delete the other. Yes. So we are refactoring at green test. We expect after refactoring the test to be still green.
And it is perfect.
Should be. I didn't see that. Okay, perfect. It took a while to get to my side. Beautiful. So now we can go to, we are still in green, so still my turn. So let's go back to the FizzBuzz test.js and let's create a new test case.
Which will be for which value?
It will be for 10. And we expect it to be buzz, but it's gonna fail.
Okay. So value is 10. This is the input. And the expected result is buzz. npm test, running the test.
Fail.
Fail. Okay, so now it's my turn. Please, let's go to FizzBuzz.js. And I like your idea with dividable by. So could you please change this input 5 for bus the same way like it's divisible by 5?
My pleasure. And format.
And now I expect the test should be green.
Let me run it for you. FizzBuzz test runs. Pass.
Super
6
duper.
pass. Beautiful.
If I'm looking at the numbers, we are safe for 2, so we will be probably safe for 11, 12, and so on. But the first tricky number in the row could be 15. So could you please test 15? And because 15 is divisible by 3 and 5, the answer should be FizzBuzz.
So let's make a case. The input is 15, should be answer should be FizzBuzz. So FizzBuzz and input 15. Let's run it. Fails.
And we are not ready for 15 yet. So tell me what to do.
So the easiest thing that I can think of here is that if input is divisible by 15, it will return FizzBuzz. So let's copy from line 4 and 5, or yes, 1 and 10, absolutely.
And where to put this code?
This is tricky. For example, if we would put it at the end, for example, between lines 5 and 6, this will not, it's not gonna work because it will return fizz because it's the first one. So let's put it in the head and let's put as between 1 and 2, exactly there. Divisible by 15 and put FizzBuzz and reform.
Control S, run the test.
Pass.
Super.
Beautiful.
So I think that we went through the basic structure of the code, but I have a question. We done some refactoring of this so-called production code, but I think that there is also place for making refactoring of those tests.
Absolutely. If we see at the structure of our test, we see that there is a lot of repetition, right? One of the things that we could do is to maybe grab all the inputs and all the expectations and have it run as a test. We already prepared something like that for the viewers here. We prepared this. We actually prepared the full test also for 4 and other numbers. As you see, it's very clear what are the inputs and the expected outputs. I will now copy paste this code and show you how it runs. And you will see there are still cases, test cases, because this thing actually creates test cases. And our application runs, as you see, all our inputs and all our outputs. And this thing has the added bonus that separates our expectations from, let's say, this for each element, this execution. This is very common when you are triangulating, separating the inputs and the expectation from the test, because the test is just one of the iterations, and this is the very basic of refactoring on the test code. Let's remember that when we refactor, we don't refactor only the production code, but we also refactor the test code.
And I have a question, because we were talking that those TDD tests are like scaffold, and they will not be used for tests as we are usually doing as testers. So how much time would you suggest for refactoring the tests?
Refactoring the test. Refactoring the test exactly the same time that you put into refactoring your production code. Because the test production code and production code test the test. The moment in which you can clear, let's say, your business cases with your test code, and you are able to more easily write your test cases with business language in your test suite, is the moment in which you can take your product owner, put it close to you, and show him, okay, I'm writing this thing. Rate what is it doing? It is what you have in mind. And you, in that moment, you are getting the fastest feedback on your work, because you will see if it executes, if it's okay for your product owner, and it can be done only with a refactored test code. So if you want to go really fast, you need also to put a lot of love in testing code.
Perfect. Now I have another two questions from our viewers, and one is you did not recommend it TDD for UI test automation. Could you please explain it more, please?
Yes. Usually UI, it's something that if you need to test your UI, you usually are working in let's say you boot up your full application, and you, for example, I can think of my favorite JavaScript environment for this. It's called Cypress. You express what your user is doing to Cypress, but you also can use there are many frameworks for that, and you click the buttons and all these things. This is very time consuming. This kind of test is very slow, and each test can take 2 minutes. If you have 100 of that, you cannot you cannot possibly develop with 2 minutes between you launch something and you get the result. You are going to lose focus. So I wouldn't recommend this. I would recommend that you take your unit in a different way, but it's let's say it's a bit of a design approach. The web should be a plugin for your core logic. So when you test your core logic in memory, and you test your cases in memory, and you, let's say, at integration test, you test only a bunch of for a smoke test every night. Let's say instead of all the possible cases, you put 10. The 10 more valuable things that your user can do with your application, you put a test there and you run it by night in complete integration. While producing the code, you work on the, let's say, on the library that has the behavior inside your system. And then when you are sure about the behavior, you use your library in the, let's say, it's the UI that imports the library. It's the UI that has dependency on the library. And in this way, you invert, let's say, that you invert the problem, and you also have, let's say, your UI becomes something that uses the use cases and not something in which the use cases are made. Because that kind of problem that I understand you have is about having a lot of logic in the controllers in an MVC kind of approach. Take that logic, put it in a service, or put it in an internal API of your application, and call just the API from your test, from your UI, please. Or you will have this test that run for 60 hours, and they will be useless because nobody will run them, and your company will fail and will be strangled by this thing.
Mm-hmm. Okay, thank you for this explanation. And there is another question. Could you please share thoughts on practices and tools whilst everyone is working remotely for pair programming? What are you using, for example, in your company? We saw one approach, how we are sharing the code exactly, and we see what the other is doing.
Yes, I tried the Visual Studio Code and also Visual Studio Normal, and it works amazingly, and it's perfect. Never had a problem. The maximum of the problem we had now that the machine for some reason closes and you have to reboot, and that is. Another tool that I tried, it's Let's Code or something similar. I don't remember. IntelliJ has the same thing, and it is a plugin right now. All of them have some Code With Me, it's called. All of them have some problems here and there. But I would say that these two are the ones that I use, and I never had big problems. We tried with also having a third machine and working two people connected to that machine, but that was challenging. It has more challenge than one would expect because, for example, you cannot share really the keyboard. You would need to have VNC, and VNC is very slow. And so I would use one of these tools, not another machine with VNC, for example.
Okay. And from time to time, we need to scribble something, doodle something on the whiteboard. And this is a big disadvantage that we are not together in our offices. What are you using for this doodling?
Me personally, I'm using MS Whiteboard or Miro. There is Mural. There are a lot of tools. I found myself with Miro or Mural to be probably the best choices. There is another tool, but it's more for sharing design.
Figma?
No, it's a Java tool. It's called Plan2ML, and it's done to write UML designs, but also supports, for example, the C4 model. And then I find that is something that I use to when I need to express something that is already designed. It's probably faster if I do that kind of model, send it to my other person, and the other person reads it, and it's clearer. So
it sounds interesting. We should definitely put links to those tools in our in our comments. So thank you for this presentation. It was very useful, and I'm very happy that we didn't do it only for our workshop participants. And I hope that we will see you more often, because I think that we can talk deeply about refactoring.
Absolutely.
I think that this is phase which is also very interesting.
Refactoring is one of my great passions, and I can talk hours about refactoring, about design, about architecture. I can become obnoxious. So yes, please.
Yeah, definitely we will invite you. So thank you very much for this evening, and looking forward to see you also in person. Bye-bye.
Thank you. Thanks, everyone.